Alright, hello Trig. So we're finishing up what we started on Tuesday, which depending on when you're watching this, could either be yesterday or several days ago, depending on how long you procrastinated. So on Tuesday, we got to the point where if we have something that has an odd degree, it either looks like this or it looks like this. And if we have something with an even degree, it either looks like this or it looks like this, and there might be some up and downs in between, but that's what our end behavior is doing. Now, the difference between these is if we have a positive leading coefficient to go with that odd degree, then we're going to end up with something like this. Whereas if it's negative, it's going to be going down. And on our even ones, if our leading coefficient is positive, we're going to end up with something like this. Again, it might have some up and downs in between depending on what exactly our polynomial is doing, but the ends are generally going to look like this, just like a right side up parabola. And if our leading coefficient is negative, it's going to be heading down. Now, the nice thing about this is we can figure out what our end behavior is going to look like without even having to graph our function. So if I've got a polynomial that, didn't throw it on here. Okay, so if I've got a polynomial that looks, say, like this, then without even graphing anything, I know it's an odd degree. With if there's not a number out there, it's a positive leading coefficient, so our end behavior is going to look like this. So our limit as x approaches infinity is going to be infinity, and our limit at negative infinity is going to be negative infinity. So without even having a graph or function, boom, we know what our end behavior looks like. Alright, now the thing we didn't get to talking about on Tuesday is real zeros. So if you hear the words real zeros, think x-intercepts. So if we want to find our x-intercepts in general, we want y to equal 0, or in this case f of x equals 0. So think back to algebra 1, algebra 2. If we want to find x here, we could factor this. Now, you could also quadratic formula this, but this one factors nicely. So we're going to find this. So we're looking for factors of 12 that are going to add up to 7, which are going to be 3 and 4, which means that our x-intercepts are going to be negative 3 and negative 4. So basically, if we can factor our polynomial out into our factors, the opposites of those are going to be our real zeros. Which means that if we have a degree of 2, the most we're going to end up with is 2 of these factors. Which means that the most of these we're going to end up with is 2. So the biggest amount of real zeros we can have is going to be equal to our degree. So our largest number of possible real zeros is going to be our degree. That doesn't mean we're always going to have that number, but that's the most we could have. Because if we have something with a degree of 2, it could have 2 real zeros. It could have 1 if it does something like this, or it could have none at all. But our degree is the number of possible real zeros. So if we're looking at our possible real zeros here, we're looking for, again, our degree, which is our biggest one. So this could have 6 real zeros. Possibly. Okay. The other thing that goes with this is turning points, which nicely are exactly what they sound like. They're where our function is turning around, it either going like this or going like this. So it stops going down and starts going up, or it stops going up and starts going down. So if we've got something with a degree of 2 here, again, because it's a parabola, we have 1 turning point. If we have a cubic function, so we've got 3 possible x-intercepts, so we got 3 possible zeros, we've got 2 turning points. So we got two possible turning points. Seeing it back? If we're over here and we've got 1, 2, 3, 4, 5, 6 possible zeros, which makes this a 6th degree function, we've got 1, 2, 3, 4, 5 possible turning points. So your number of possible turning points is 1 less than your degree. So your degree minus 1. And again, it doesn't mean it always has that number, but that's your biggest possible number of turning points. All right. Now we're going to do a little bit where we're actually finding our real zeros. Now, if it's nice and quadratic, you can either quadratic formulate or you can factor it. If we got something like this, we got a little something we got to do first. So what do all of these terms have in common? Hopefully it said they all had an x. So we're going to factor out an x before we do any of that other stuff. So we're going to factor out an x, which leaves us with an x squared minus a 4x minus this 5. Oh, well, hey, we can factor that. So we're looking for factors of 5 that are going to give us 4. So you got 5 and 1 are really your only options for factors of 5. And then if we want to end up with a negative 4, we want a negative 5 and a positive 1, which means that our real zeros are either x equals 0, x equals 5, or x equals negative 1. Okay, let's do one more of those. So if we've got this, okay, so we can't factor anything out of these, because these do have an x, this one doesn't, these are divisible by 2, that one's not. So instead, we're going to factor this, where we're going to have, instead of an x, we're going to have an x squared. Because if I have an x squared times an x squared, I'll get my x to the 4th. But now we're doing the same thing. So we're looking for factors of 8. Factors of 8. Well, I've either got 1 and 8, or I've got 2 and 4. Really, those are your only options. But conveniently, 2 and 4 give you 6. And no, it doesn't matter which one goes where. What does matter is they're both negative, because we want this to end up being a negative 6, and the negative times the negative will give you that positive 8. So now if we want that to equal 0, we've either got x squared minus 2 equals 0, or we've got x squared minus 4 equals 0. And remember, this was a 4th degree polynomial, so at most we're looking for 4 real zeros, which is nice because once we add a 2 and square root this, anytime we have a square root, we're going to get a positive and a negative of that square root. So over here, we're going to have a positive and negative square root 2. Over here, that's a 4 in a line, we're going to have a positive and negative 2. So there are our 4 real zeros. This time we had 4. Might not always end up with 4. And any of these ones, feel free to, once you've got your answers, pop over to Desmos and graph it and see if those are in fact where your zeros are. If they are, you did it right. If they're not, something went wrong. All right, now, if this means that we have zeros here, the last thing we're going to do is we're going to go in reverse. So this means that if we want a polynomial with zeros at 1, 2, and negative 4, all we have to do is throw some parentheses here. So these are going to be our factors, and we've got 1, 2, and negative 4, so we got 3 of them. So if x minus 5 gave us a 0 at 5, and we want a 0 at 1, we're just going to go x minus 1, x minus 2, and x minus a negative 4, or if you want to call this an x plus 4, that's also fine. Now, you may notice that's only a third degree polynomial. That's 1, 2, 3. So if we want a degree of 5, we're going to end up repeating some of those, which you could either write out like this, so you can just write them out again and say, well, I want to repeat this x plus 4 twice. Or the other way you could write that is you could say, well, x minus 1, x minus 2, and then x plus 4 to the third. Or you could say x minus 1, say squared, and x minus 2 squared, and then an x plus 4. So these ones, there's going to be more than one option that would be fine. And any of these, you can throw a number out here. You can throw a 3 here, and that wouldn't change any of my zeros. Okay, let's do one more of this. So if I want a polynomial function with a degree of 4, but I only have a real 0 at 7, that means my only factor going on is going to be x minus 7. And then I just want that 4 times. And instead of writing that out 4 times, I'm just going to do that. I mean, you could write it out 4 times, but there's really not any good reason to. All right. So that is the rest of polynomial functions. The assignment, it was already up on Google Classroom because I put that up on Tuesday. So if we are back in school on Monday, feel free to just hang on to that and hand it to me then. If we're not back on Monday, go ahead and take a picture of that and either upload it to Google Classroom or email that to me. Either one of those things is fine. And fingers crossed, hopefully I'll see you guys on Monday.